Thanks, folks. We're going to do this after lunch. For anybody watching this video afterwards, we're bringing the energy to overcome this. And we're going to do that by talking about spite. Spite can be one of those extremely powerful motivators and a bit of a double-edged sword. I think we all know somebody who's sort of the negative side of spite. But it's also one of those things that could be harnessed, I think. We've probably heard the phrase, Carlin said it, right? Behind every cynic is a disappointed idealist. I think behind a lot of spiteful people, not everybody, is a person with an overactive sense of justice. And that, I think, can drive a lot of really interesting things. Maybe people found companies on it, maybe people become hackers on it. But in this case, we're going to talk about how spite drives some horticultural analysis. And we're going to frame it in that discussion. So horticulture is growing stuff, and we're going to talk about tulips. And if you're not familiar with tulips, how tulips work is they're bulbs. You plant them in the fall. They overwinter because they need a dormant period, and then they come up in the spring. So I've got a buddy who works at a large horticultural institution. They do tens of thousands of tulips every year, requires volunteers, a bunch of staffers, etc. They put them in, and then they cover them with straw. And then in the spring, they have to take the straw off because for a bunch of reasons, and then the tulips come up and they look great. So they cover them with straw because about 25 years ago, there was an issue with their yield. They had a bunch of tulips who didn't come up. It was a rough year. And someone said, I know, let's cover these with straw because that'll help stuff. Why was the reason? There wasn't really a lot of science behind it, but that's okay. And so why did my buddy was talking about this? He's complaining because he says, we got to pull up this straw from the ground. It's moldy. It's nasty, right? It's been sitting all winter long. It damages the plants, requires a ton of work to do it, right? And he's like, I wish there was a better way. And I said, well, why don't you do that? Well, because when he asked about it, he was told, hey, stop asking questions. This is the way that it's been done, and you don't need to know this, right? All these things which, if you've been in security, you hear these, right? I used to be at Idaho National Laboratory, and one of my favorite stories to tell is we got some equipment sent our way, and we were doing vulnerability research on it, right? They send us stuff, we hack it, tell them how we broke in so that they can fix it, right, from the vendors. So they sent us some stuff, but their person couldn't show up for a week. So we set it up ourselves, hacked on it, and we found a couple critical vulnerabilities in the first week. And so we told them about it, and they said, you guys are liars. You didn't do any work. And we said, well, what do you mean we're liars? They said, well, our person didn't even come out there to tell you how it works, so you couldn't possibly have gotten it running or stood up any of the stuff before. And that created a lot of spite on that project. And actually, in hindsight, I think they were either bad or geniuses, because after something like that, our team worked extra hard to find more bugs and report them. So they probably got more work out of us than most folks. One of my favorite quotes is, the greatest pleasure in life is doing what others say that you cannot. And that's what's kind of, as I've gone through security, doing things like bug finding, starting a company, trying to help solve solutions, taking on huge competitors, right? Like any time that you can go through life and kind of do some of this, it feels good when you can be right and when you can bring legit experience in data science and help make good decisions and improve things. But lesson number one is beware the bias of experience. Experience is great. It is absolutely important, and we should listen to the experience and the documentation and things that we have. However, it's not always right. So quintessential example is you take the same commute to work every day. The city improves things, builds a new road, widens the road or whatever. If you never reevaluate your route to work, you might not be taking the most efficient route anymore, right? And we do the same thing in security. If we don't reevaluate some of these things. That's why I'm pretty passionate about education and bringing in new ideas and getting new folks into the field. If we don't bring in new ideas and reevaluate some of the stuff we've taken for granted, we're probably missing out on some opportunities for that. Maybe there's better ways to look at the problem. One of my, the IBM cost of a breach report, if anybody's familiar with that, one of the statistics from there that I find super interesting is the average attacker dwell time. Right, so bad guys are in already, and they've been there. The average amount of time that they're there before anybody finds them and kicks them out is 300 days in their last report. 300 days. And that's up from their previous report. So maybe there's some things that we could be evaluating better. And as someone who's pretty passionate about logging and observability, also, and maybe a lot of you folks out there too, how many days of logs do you have? And those things don't really match up. Often it's less than 300. So beware that bias. But back to our story. So we had, my buddy and I had a couple hypotheses. The first one is tulip bulbs that experience temperatures that oscillate above and below freezing are less likely to produce yield. That's one hypothesis, which I'll just tell you right now, we didn't really get a good chance to test because they haven't come up yet, because it's still pretty early in the year. But planting depth and bed coverings have a significant impact on bulb temperature variance, is the other hypothesis, and that was the main thing for the experiment that we were doing. So what we did for plant nerds and data nerds, what we did was we created 3 different beds, or 3 different configurations of coverings, and then 3 different configurations of planting depths. So if you don't know much about tulips, tulips should be planted at 6 inches. That's usually what the manufacturers, as if they make this. They are not God. But they do produce bulbs and sell bulbs. And they say 6 inches is best. But what's important is at these institutions, right, and this is also true in security, right, you've got some elements of human error in this. And so sometimes the volunteers planted at 4 inches, or maybe people are getting a little bit lazy and they might do 2. So we wanted to check and see how that impacted things as well as what we use for covering. So we compared covering it with nothing, covering it with straw, which is what they were doing, and covering it with compost. Because my buddy said, hey, we have to put compost on these beds anyway. And if we just cover it with that, maybe we can kind of kill 2 birds with 1 stone and be super efficient with what we're doing. And this year turned out to be a really good year to test this because of atypical weather. There were more days near freezing in the area where this was, and so it was a good time to run the experiment. So the plan was we're going to buy some really cool garden IoT and get a bunch of these sensors and then grab these logs and readings. Lesson number 2 is this is a process, not a product. And this Schneier said this years and years ago. It's just as true today as it was then for security as well. So we went out, looked for some IoT components that promised, oh yeah, we're going to do this. This is going to be great. You're going to be able to monitor everything. No, they sucked. They didn't work the way that they said they did. Everything was breaking. And so we made it ourselves. So I built it out of this in order to do these things. Out of the box often fails. And this is also true in security. Your organization is unique. No 2 organizations are the same. And if you're not doing things to benefit from that defender's advantage, then you're missing out on a lot of opportunity from a security perspective. So let's talk about what we built. I called it Garduino because that sounds cool. So it's actually, I open sourced the whole thing. It's a pretty trivial project, really. But if you wanted to do such a thing, the code's up there. That's where the URL is. But we use an MK WiFi 1010. So this is just an Arduino that has that blocks there. That's the Wi-Fi chip on the board to be able to communicate with Wi-Fi, which is great. And then I used a one-wire sensor network with, so this is Dallas one-wire for temperature sensors. Works a little bit kind of like CAN bus in that it's digital, and then you can chain a bunch together, which is cool. Then tested out some moisture sensors as well. So the one wire was for temperature. This is for moisture sensing because it would have been cool to grab that type of data. Moisture sensing didn't end up actually working. It was an analog read and suffered from some elements on that. And then one of the things that I did was we wanted to calibrate these things. So even though we bought all the same sensor from the same manufacturer, they were each off by different variants of degrees, right? So this is also kind of a little mini lesson of your sensors also kind of need calibration and things too. This is a little bit less of a problem with cybersecurity sensors because of the digital supposedly deterministic nature of computing, but it is still, there's still something to be learned here. So we calculated, for this sensor, how did it read this compared to everything else and create these baselines, and then we would enrich the data with that later. So bonus lesson around custom logging. So Gravwell is a logging analytics observability platform. So logging is something that I'm pretty passionate about. It's something that we deal with at huge enterprises at massive scale, terabytes and terabytes a day worth of logs. But there's a couple logging do's and don'ts that came into this that I think are pretty important, especially if you're doing any sort of custom logging. And so we'll talk about that. You want to log atomically. That is, the log itself should represent what happened. So bind is kind of bad at this. If you're familiar with bind DNS, it'll say something like, oh, a request was made for this. And then it'll say this request came from this IP. And you have to merge like 3 or 4 different things together to get the same log that you would out of something like DNS mask or some other service. You also want a timestamp and log more. Some don'ts. You don't want to require context. The person should not necessarily have to have context for a log. Sometimes that's unavoidable. You don't want to be ambiguous with your logs, and you don't want to assume the use of the log entry. This one's actually a big one and kind of a subtle gotcha. You don't want to assume what someone is looking at the logs for, especially because, right, as security people, we look at logs that are coming out of these IT folks, maybe custom services or whatever, right? You got a custom service, and it's going to spit out some logs, but from a security perspective, we have different goals than what the engineers did when they wrote them. And if they can make it such that, this facilitates multiple goals, that's ideal when you're doing any sort of custom logging. And don't try to be clever. Let's look at a couple examples. This is an example of bad being clever. So this is a literal real product that puts out a log like this. And if you're familiar with JSON, this gets absurd pretty quickly. So JSON, right, you notate by saying foo.bar.baz, right? That's how you refer to objects or properties within the JSON. And they created their object that was literally called .tag. So if you want to reference that property, you have to say event type .tag, which is stupid and breaks all kinds of stuff. And then they're not even consistent because at the bottom of this you have asset underbar .tag as the single property. Don't try to be clever. Just keep it simple, stupid. Applies to logging as well. And then here's an example of ambiguity. So this comes out of a real product as well that does EDR, right, endpoint, like this executable ran. It's hard to tell the difference between the binary path and the arguments to the executable in this example. There are ways to get that from the operating system when you're doing these types of logging, but they just mushed it together in one, and then it becomes difficult to say where does it end, where does it stop, et cetera, because all these characters are valid for paths, they're valid for arguments as well. Okay, so here's what I made from UDP stuff. So the Garduino just sends UDP messages out to a Gravel logging server. This is kind of what they look like. Created some for system initialization here. I named the host Dirty Harry, and I had a second one that was called Soil Sally as well. I think we can agree that those are the best names that you could come up with for this. Include the time, include Wi-Fi strength, and then some messages in this key value sort of format. This is what the temperature messages look like, though. Once it's up and running, these are sending constantly. I just have, hey, here's the sensor address, here's the value. And to give you an example, like when you're talking about the context, right, I have the sensor address in here. And the reason I do that instead of saying like, oh, this is bed 3 or this is this particular configuration is exactly to separate that out so that when someone's analyzing this, they can separate it from the context requirements, right? And then you might have a separate log entry that says, here's the configuration at this time. Or if I move, sensor 28EFD, if I move it from this bed to this bed, I have a log of that I can correlate with these. That's much better than saying this is in bed 1, because then if I move it and I don't reconfigure this machine or whatever, then it's going to fail, and my logs are no longer perfect. Then I have to do some weird stuff. So that's an example of that. So the main Arduino loop looks like this. If you've ever done anything Arduino, it runs in a loop, and then I'm delaying or sleeping for a second. So every second, it's going to update the temperatures, update the moisture sensor. Every 10 seconds, it'll do an NTP update and then send that out. So this is this is a Gravel interface, but this is just looking at temperature data coming from all these sensors. And you can see clearly where the Arduino does NTP update, because Arduino is going to be single thread or whatever. It's got a single execution, and so everything else stops when it does the NTP, which I thought was kind of a funny chart. In the end, it doesn't matter because a small gap in there. But I do want to talk about why we do NTP, and I'm going to rant about time because that's what we do, right? And logging, if anybody's done logging at scale or anything like that, even not at scale, time is a nightmare. Time is a nightmare, and this XKCD, there's an XKCD for everything, but I got to put this one in here because, yeah, anybody who's worked with it is like, okay, event 1 happened at time T1, all right, event 2 happened at time T2, so how would you calculate how much time passed? And it's definitely this bottom box. Anybody who's worked says it's impossible, and it's a sin task. Time is a mess, and so the more we can try and make that together, the better. Another rant, the only correct time format is ISO 8601. If you are not doing this format, you are wrong, and you should stop and change it immediately. A lot of that's out of people's control, right? These are your vendors or whatever. But I want to say that at this point, the clever members of the audience, or people who are watching this, may start to build a little spite toward myself which I highly encourage, because if I go back here to the messages that I'm sending, I don't use that times format. So I'm a hypocrite and deserving of your spite for this. Why did I do it? Because this is what the library did, and I didn't change it because I'm lazy. Right? That happens all the time. And so we can try and do better, but, you know. Okay, and so once I've got those logs, I'm going to collect them into GravWell. Just a real quick, so GravWell, we do log analytics, observability, that's our thing. OT, IT, closest thing would be like we're a Splunk alternative, is the fastest way to say it. Not necessarily an Elastic alternative, if that means anything to you. So the reason that we use this is because I want to collect raw data. I don't want to clean it up. I just want to throw the data in and sort it out later. I want to extract fields on the fly. I want to generate ad hoc analytics and aggregate searches. And I want to enrich it with third-party data like weather data and other things because I didn't end up getting a temperature or a temperature sensor for the air. I didn't end up getting a humidity sensor. And so I needed to pull that from National Weather Service. It's also free for personal or commercial use. So please, if you have projects at home, home labs, or even at work, and you need something to take logs in, this is free for you. And we can bump that up if you need it. So the plan versus actual. We were going to do all this stuff, but we ended up with an Arduino, ended up with just a temperature sensor and data feed enrichment for weather. And then we're going to send those network readings out every second is what we're going to do, which some people think, oh man, do you need a temperature every second? That's a lot of data. We deal with terabytes of data a day, so I don't care. Just send tons of it. So here's what it looks like just as a picture under the hood. I used a couple screw terminals for the one wire so that all these are connected, and I tore apart some Ethernet cables to go out to the different places, and then you see the little Arduino there. Kind of a cool thing, and then that sits on our box. So let's dig into the data. I'm not sorry, but you knew that at some point there was going to be a pun about that. Okay, so here's the experiment layout. I'm just going to talk about this in coding briefly. So we had three different configurations. So the D is how deep we planted it. The S is for a straw covering and how many inches of that straw covering. So we only did 2 inches of either straw or compost. So the top one there is, so 6D, 2S is 6 inches deep with 2 inches of straw. 6 inches deep with 0 inches of compost, and 6 inches deep with 2 inches of compost. Okay, so here's what the chart looks like. Here's just a period in January of all the different sensors that we've got. Hopefully the colors come through, but if they don't worry, because we're going to dig into it. So here's the 2-inch depths. So for when you plant these bulbs at 2 inches, they only have 2 inches of soil around above them. You can see that bottom line is going to stay consistent through all these charts. That bottom line is the air temperature. So that's the air temperature. That's what the National Weather Service reported for the area. So air temperature moves, and then you can kind of see how it drags the temperature of the soil down with it. You can see that for all of these at 2 inches depth, the next one is the 0 inches of covering, which is totally expected, right? We just do 2 inches with nothing on top. That's pretty jagged, moves along with the air temperature as it goes. But even covering a 2 inches with a little bit of straw or a little bit of compost really dampens how much movement there is with the air temperature, which I think is fascinating. Also, snow works for this too, but that's why I said this is a good example, because we didn't have a lot of snow this year, and so the covering mattered a lot more. But snow will also serve as a big blanket for things as well. And so this is with 4-inch depths. And so already you can see, right, going from 2 inches to 4 inches stabilizes things even without any covering, but without covering, it's still, that air temperature is pulling the soil down, and temp is pulling it up as the sun comes up and whatnot. But those coverings start to even out. And then here's a 6 inches one, which is even more stable, right? And the air temperature has less effect. And so this, even just right, these bottom lines are all the coverings, right? The folks who say, here's where you should plant your tulips are absolutely right. Once you hit 6 inches, it starts to be more of a straight line. And if you cover it at all and get some of that insulation, that's where it evens out. What I think is also interesting is, here's completely uncovered, but here's what the compost covering, 2 inches of compost covering, and then 2 inches of straw covering. So if we look at this, right, comparing the compost and the straw does a pretty good job of, or a better job even than the compost, of kind of stabilizing that 2-inch depth. But at 4 inches and 6 inches, it's kind of a wash. And so a reminder of the hypothesis as we go into this, right, I'm just going to say the bottom one, we're planting depth and bed coverings have a significant impact on the variance. So we've been eyeballing this. This is just a straight, here's the average temperature. That's what these charts have been. But it wouldn't be data science if you're not flipping and twisting and looking at data in a bunch of different ways. And this is highly encouraged if you're doing anything related to security, you're looking at any of these kind of metrics and you want to dig and twist them. This is Gravel search syntax. It's pretty much kind of Linux command line-esque, if you're familiar with that, or super good at PowerShell. This is what it looks like. But by changing it from calculating the mean to calculating the variance, and then looking at this. So what we're seeing on this chart is the variance, which is the rate of change of these things. The super spiky line is the 4 inches of depth with no covering. And you can even see, especially on this chart, right? This is where visualizations and flipping the data and looking at it in different ways really helps us stand out. Because on this chart, it's extremely clear that as soon as you put any sort of covering on here to provide some insulation, that variance almost drops to 0. And so this type of visualization is also great for variance on domain names or calculating entropy for your domain requests and stuff like that. And so in that example, if you have somebody doing like a DNS exfiltration, like an attacker is exfiltrating data out over DNS, you might run into frequency analysis, entropy analysis, variance and things. That's how you can kind of build indicators that are native to your environment. You train these types of things and baseline it based on what you're seeing. And then you can catch bad guys with the same type of techniques. But in this example, we are arming my buddy with some material to go and try and make change. This is just another way to kind of visualize this. I don't like this one as much. But in terms of how much variance is there across the whole thing, where is it mostly? It's in the uncovered stuff. So lesson number 3, though, I want to talk about this a little bit. You got to be careful what you measure. A useful metric ceases to be useful once it becomes a target. Useful metric ceases to become useful once it becomes a target. Because then people alter their behavior so that they can get that target and do what they need to do. If you pick one KPI, which in this instance we were kind of like, well, we want to reduce the variance. If you pick one KPI, you might miss out on the better overall solution. Because the greatest reduction in variance was indeed straw. It turns out that the data supported this decision that was made without data, which works out sometimes, that's great. It was made by experts who know what they're doing, right? And so they can go with their gut feel. And sometimes the gut feel is right, and in this instance it was. Straw did reduce the amount of variance that was out there, but the greatest impact on the organizational mission is clearly compost, because you're getting very close to the reduction in variance, and you are saving all of the man hours required to put the straw out and pull it out, because you've got to put the compost there anyway. So if they move their compost addition from the spring to the fall in support of their tulip planting, they're going to be way better off. And so, armed with data, our heroes confront the establishment. And here's the management data report evaluation area, because it didn't go well. So lesson number 4, with humans, there are always hidden forces at work. Why are people resistant to change, right? You bring this stuff up. Why is this happening? Why aren't they following the conclusion of the data? Well, is there a reputation at stake? Are they going to lose face? Is there something else going on, right? We see this in security a lot. Security sort of by nature starts to butt up against humans with phishing, and people don't feel good when they get phished by something, and so they don't report it. And that's a problem, right? We need to be aware of the human factors that are involved in all this stuff too. And so in this example, truth is stranger than fiction, because to be honest, I was sort of fantasizing with my buddy. I'm like, yeah, I'm going to tell this story, and when I do it, I'm going to say, what do you think if I made up this scenario? Because, to quote Gandalf, every story deserves every good story deserves embellishment. And so I'm like, yeah, what if I say, hey, maybe there's like a straw mafia, and your bosses are involved in the straw mafia, and there's this thing going on. And he goes, actually, the person who supplies the straw is the family of one of the managers at this place. So they did stand to lose monetary value if that decision was changed. So they were part of the straw mafia, and the straw mafia is real. And that happens in security too. So to wrap it up, lesson 1, beware the bias of experience. We want to use experience, but you got to look for other options out there. Be aware of the other alternatives. Bring in fresh blood. Bring in new people to check out. Be okay with challenging some of the status quo sometimes. All right? All that's got to be within reason, of course. Number 2, this is a process, not a product. That's going to be true forever. For everything we do in security, always. Everything we're doing in data science, you're going to build a model, you're going to test it, you're going to need to tweak it, etc. That's how this works. And if you're trying to solve it by buying something or checking boxes, you're not going to get very far. But your metrics might look great. Your targets might look great. So be careful what you measure. Because if you're saying, oh, we want to improve our cybersecurity, and here's how we do it. We stopped 3,000 attacks yesterday, and we're going to stop 10,000 attacks today. And then somebody goes home and a stopping attack from a firewall vendor might say, oh yeah, I blocked a port, right? And then somebody goes home, fires up Nmap, and then, no, the firewall reports that we blocked all kinds of stuff, so our cybersecurity is doing great now, right? You got to be careful of that. So be careful which metrics you're choosing, be careful what you set your targets to. And then with humans, there's always the hidden forces at work. We need to be cognizant of that. And I think fighting it is a losing battle, right? We realize that we're dealing with humans. That is the #1 way that organizations get breached, and it probably will be forever. So we got to figure out how to deal with that element as well. So that's it for me in terms of actual content. Thank you very much, and there's time for questions if anybody has any.
How did the tulips turn out? Is this still a work in progress?
Yeah, yep. So the tulips themselves, that's what I mean. The first part of the hypothesis, we haven't been able to test it yet because, yeah, it's still spring, and so they haven't come up yet. But yeah, some of the part that's funny is even the 2-inch ones, especially after some erosion and things on the soil, the bulbs started just kind of popping up, and they're almost sitting on top of the ground now. But they're also sprouting and things too. So I find that kind of interesting. So sometimes that nature finds a way, or Jurassic Park, life finds a way somehow. So yeah,
thanks.
That's a good question. Yep. All right. Well, I hope this was a helpful foray into horticulture and a good framing for some of the things that we deal with in security all over the place too. Thanks for coming, and happy to talk to anybody afterwards as well.